Hey guys, how's everything going? This is JSer. In this video, let's take a brief look at what was new in TypeScript 4.8. I actually don't know when this was released, but I think it's pretty recently. So the first important update is about the unknown is now is closed in spirit. What the fuck is this? So it's closed in spirit to the union. This is object, null, and undefined. Well, I think it's pretty reasonable, right? Because unknown. So for all the data types in JavaScript, even though the primitives actually has this wrapper object, so we could treat everything that is not now and or undefined to with this and with this literal. So yeah, I think it's theoretically identical to unknown, but I don't know the internal implementations of TypeScript, so maybe this created some vagueness. But anyway, I think it's pretty reasonable. So for now, we actually could assign this union to unknown or unknown to this union. So one interesting thing is that because now this word, the non-nullable, could be written in a way that is much simpler. Like this one just intersect with object, so this will exclude the null and undefined, so it will become non-nullable. If it's not, we need to use extend, doing the other way around, right? Well, this is not complex either, though. So this has solved the TypeScript quirks before, like this one, non-nullable. It's non-nullable. It is actually not nullable. Let's see what it happens before, like at 4.7. Why? This one is non-nullable, but this one you cannot assign it the other way around, because why? It says non-nullable is not assignable because T is not assignable to non-nullable. But anyway, I think that's related to how extends works internally. But now it works because of the simplification about how this is written for non-nullable. Wow, this is cool. The other thing is that for this kind of function, before it didn't work because the TypeScript won't do the type narrowing if it is unknown, right? If this type is undefined or now, the other way, the other branch should have some non-nullable T, right? This is obvious, but it didn't work before. Now it's possible. If we switch to 4.9, it totally works. It's T intercept with this object literal, so it's non-nullable. Also, there is something new called the extend constraint on infer types. Let's take a look at the example. So this try to get the number if first is number. So from this we can see that it says if the first one is number, then get it. Otherwise, never. So this is actually something new introduced in 4.7. Actually, left it over. Extends, yeah, here. So here's a typeset. If it is string, we get if the first one is string, let's get it. We could write it as like this one, infer s is to get the first one, and then we say if the first one is string, we s, but if not, we go to never and never. So this kind of nested ternary. But TypeScript 4.7 makes it simpler. Say if you want infer, we could combine these two together, infer s. If it extends string, so it become easier, simpler. Looks obvious, right? So what's it new in 4.8? It says if the infer types appear in a template string type and are constrained to primitive type, TypeScript would now try to parse out a literal type. Some num used to be number, now it's okay, so this is a string literal. We get if u is number, and then we get U is never. So it says it's number, but now it's that I'm a bit confused about the quotes here, and also the syntax highlight. What the fuck is this? Let's put it here. Let's see what it is. The sum num is number. Jesus. So actually it okay. It has this type coercion, right? It transform. Oh, we can now easily transform the string to number. I think we cannot do that before. If we need to like iterate. So if it is a float, what it will be? Oh, it cannot be float. Yeah. So it can only be primitive type. It can only be integers. Yeah. Okay. But anyway, it's much better. I think if we want to, without this, if we want to convert this into a number type, literal type, we need to like accumulate 1 to 100, right? It's kind of very not performant. Okay, negative. It's, you can see it can do. Wow, this one is cool. We can have the negative number. Okay, it also can convert it to the big int, and also extends to boolean. Wow, this is awesome. Yeah. Try to parse out a literal time. This one is so cool. Yeah. Yep. Okay. One note of this is that parse literal will greatly try to parse out as much as what looks like of the appropriate primitive type. However, it then checks to see if the print back of that primitive type matches up with the string contents. In other words, TypeScript checks whether the going from the string to the primitive and back matches. If it doesn't see the string can be rounded, tripped, then it will fall back to the base primitive type. Oh, see, this is number because TypeScript parses this one. It turns out it's to 1. So yeah, this is 1. So string is 1. It doesn't equal to 1.0 in string, so it will just be a number. So the same goes for a fraction here. Oh, I see. Oh, it's the same. Yeah. This is cool. I love it. That's I think that's for 4.8. There's nothing fancy, but the improvement of unknown is super helpful. If you have written code about handling the unknown types, especially for server-side Node.js code to accept some data from the client side, there will be a lot of assertions of unknown types. Actually, I'm doing that a lot. This one will help bring my code in a cleaner state. So here I usually assert something like to avoid the type errors, but now we have the TypeScript is becoming much clever now. Cool. Okay, that's it. I hope it helps. See you next time. Bye bye.